Hello again. Today we'll be talking about factors and primes. So, talking about factors, well, I'm going to use kind of an example just to kind of explain what factors actually are. Anna has 8 apples. She wants to divide them equally among her friends without cutting any apples. So that's the important thing. We're not cutting up the apples, we're keeping them whole apples. How many ways could she split them? So, she has 8 apples here. Well, how many ways could she split them? Well, what she could do is, let's say she had 8 friends. So remember, she has 8 apples. She could give 1 apple to each of her 8 friends. So we're not splitting any apples, we're not cutting them up. We could just give 1 apple to 8 different people. Well, we could also give 2 apples to 4 different people. Yeah? So that would be 2 apples to one person, 2 apples to another person, 2 apples to another person, and then 2 apples to another person. So that would be 2, 4, 6, 8. Another thing we could do is we could have 4 apples and give them to 2 people. So, I don't know, let's say Anna could take 4 apples, and then her friend John could have another 4 apples. Or, Anna could be really greedy. She could be by herself, and she could take 8 apples. So these are all the ways we could kind of divide up the apples to people. Now this, what we're actually doing is we're actually finding the factors of 8. So we have, what a factor actually is well, what two numbers multiply together to get 8? And there's not just one pair, there's multiple pairs. So let's say, well, we could say 1 times 8. That's going to be equal to 8. 2 times 4, that's going to be equal to 8. 4 times what is going to be? Well, 4 times 2 is going to be equal to 8. Oh yeah, 8 times 1 is also equal to 8. So remember, 1 times 8 is the exact same thing as 8 times 1. If I swap these around, so if that was an 8 and that was a 1, that's the exact same thing. So we call these factor pairs. What do I mean by pairs? Well, 2 things, like you have a pair of shoes. So the pairs are 2 numbers that multiply together to equal 8. Now, when I say 2 numbers, I mean 2 whole positive numbers, just to be clear. That's what we mean by factors. Yeah, so how many factor pairs are there? Well, there's 1 times 8, 2 times 4. Well, 4 times 2, that's pretty much the same thing as 2 times 4. And yeah, there's 8 times 1, but that's the same thing as 1 times 8. So really, there's 2 pairs. There's 1 times 8, 2 times 4. That's it. Now, that's factor pairs. If we're talking about factors, well, that's all the numbers that are involved in the pairs. So there's 1, 2, 4, 8. Those are factors of 8. Now, another way to think about factors, going back to the apples, is how many ways we can divide the number. So like, let's say now, not how many ways we can divide the number, but what numbers divide into that number. So let's say 8, yeah? Well, 8 can be divided by 8, yeah? That's 8 divided by 8 is just 1. 8 can be divided evenly by 4, yeah? 8 divided by 4 is 2. 8 can be divided by 2, because 8 divided by 2 is 4, and 8 can also just be divided by 1. So a little caveat of this is every number, any number you can think of, 1 is going to be a factor of it. Now, why is that? Well, think about it. Let's say I pick a number 20, yeah? Well, I know 1 times 20, that's going to be a factor pair, yeah? So let's say in questions, you might be asked, well, write down the factor pairs of any number. Well, you can write down one straight away. You can say, well, 1 times that number is going to be that number. And then you're going to have to think about, okay, well, what other numbers multiply together to get 8 or 20 or whatever number you're working with. So how I like to do this is I start off with 1. Then I say, okay, well, 1 times 8, that's going to be equal 8. Then I'll try 2. 2 times something, is that going to be equal to 8? Yeah. 4. 2 times 4 is going to be equal to 8. Then I'm going to try 3. Okay, 3 times something is equal to 8. Is there an answer? No, because look, 3 1s are 3, 3 2s are 6, 3 3s are 9, so it's not, you can't get 8. Then I'll try 4. Well, suddenly I'm back to, 4 times 2, because it's going to be 4 times 2 is equal to 8. And then once you get above the halfway point, once you get above the halfway point, you're not going to find any more. So 4 is half of 8, you can't get any more, so that's it. Then the last one's going to be 8 times 1. Now we also said we'd talk a little bit about prime numbers. So the reason I'm kind of doing prime numbers and factors together is there's a reason. Because prime numbers are special numbers. Because remember when I was talking about factor pairs, and every number has 1 times itself, that's going to be a factor pair. Well, some numbers are special because that's the only pair. So let's say 7. 7, okay, well, 1 times 7 is equal to 7. 2 times something is equal to 7? No. 3 times something is equal to 7? No. 4 times something? No. And then it's just going to be 7 times 1. Let's say we pick number 11. Okay, well, 1 times 11 is 11. Is 2 times something equal to 11? No. Is 3 times something equal? No. And I can go through all the numbers, and there's no other factor pair. So prime numbers. What are prime numbers? They're numbers that only have 1 factor pair, 1 and itself. Now, another thing to think about with prime numbers is the way you might have learnt it is, well, it's a number that can only be divided by itself and 1. So remember, factors are just numbers that that you can divide into the number. So do you remember back here we had 8? We can divide 8 by 1, 2, 4, and 8. Well, 7, you can only divide it by 1 and 7. There's no other number that divides evenly into it. And it's the same for all these prime numbers. And there's an infinite amount of prime numbers. So what does this mean? If I picked 23, the only number that we can divide into 23 is 23 and 1. No other options. While let's say if I picked 22, well, there's lots of options. I could pick 1, 22, I could pick 11, I could pick 2. There's probably other ones now that I'm forgetting, but there's lots of numbers that can be divided into it. So prime numbers are special because they can be only divided by their themselves and 1. They only have 1 factor pair. So some recap questions that you can try yourselves. I'll give you a second. You can pause the video and have a go at them, but I'm going to go through the answers. So what are the factor pairs and factors of 12? So the pairs: 1 times 12 is 12. 2 times 6 is 12. 3 times 4 is 12. Now I'm going to keep on going. 4 times 3, well, that's the same thing as 3 times 4. 5, does it go into 12? No. 6, well, 6 times 2, well, that's I've already done that. So, and I'm above the halfway point. Remember, once you get to 6, or whatever half the number is, you're done. So those are the pairs. And I know, you could change it around. You could say 12 times 1, or 6 times 2. It doesn't matter. And the factors, well, it's just all these numbers here. So it's 1, 2, 3, 4, 6, 12. Again, I'm going to say this again. Factors are numbers that divide evenly into this number. Factor pairs, those are 2 numbers that multiply together to make the number. Okay? So, is 59,892 a prime number? Now, you're probably thinking, how would I check that? Now, remember, a prime number is a number that can only be divided by itself and 1. Now, what does that actually mean? Well, if you go back to this list here, notice all these numbers are odd. Now, exception for 2, but all these numbers are odd. What do I mean by odd? They can't be divided by 2. Well, that's the definition of a prime number. They can't be divided by 2. How do I know they're odd? Well, if you look at the last digit, so see the way 7, so at 17, the unit digit is 7. Or if I look at 89, that unit digit is 9. How do I know if it's odd or even? You just look at the last digit and you say, okay, is that an odd or an even number? So let's say 59. Well, I forget the 5. 59. Is 9 even or odd? Can it be 9 be divided by 2? Well, no, it can't be divided by 2. So this number here is going to be an odd number. Now, look at this number, 59,892. I'm going to forget all the rest. I'm just going to go to the very last digit, the unit digit 2. Is that an even number? Yeah, it is. It can be divided by 2. And so is 59,892 a prime number? No, it is even. So it is divisible by 2. Yeah, because if you divide it by 2, I don't know exactly what it is. What is it? 24,000 and something, I guess. But yeah, so it is divisible by 2. You can check your calculator. You can check it. It is divisible by 2, so that means there's more than one factor pair. There's multiple factor pairs probably, so it is not a prime number.